Hi, my name is Sarah, and I'm a museum educator here at the Missouri History Museum. And this is one of our gallery stops for our April Virtual Homeschool and Learning Day, STEAM through Forest Park. And this gallery stop is going to be all about Forest Park and water filtration. Now, many of you are probably familiar with Forest Park and have maybe even visited. You might think of the zoo, the Muni, all of the museums. But Forest Park has been around for a long time. In fact, it was established in 1876. And Forest Park didn't always look like it does today. In fact, it looked a lot more like its namesake, like a forest. So you can see some images here of what Forest Park used to look like. You can see there are lots of trees and bushes and overgrown grass. I want you to take a moment, and in a second here, you're gonna pause, and I want you to look at this image and think about, what do you notice? How is Forest Park from the 1800s similar or different to the Forest Park we know today? So Forest Park has changed a lot. And one of the main reasons that Forest Park changed so much is the 1904 World's Fair. Now, the World's Fair was a huge event that happened right here in St. Louis. And people from all over the world came right here to experience the fair. Now, when it was announced that St. Louis was going to be the one hosting the fair, they weren't quite sure where to put it. There was lots and lots of debate. A lot of people wanted it closer to downtown, where it'd be easier for people to travel to, especially because at that time, a lot of people would have been coming on steamboats. But the World's Fair, like I said, was a huge event, and they needed lots and lots of space, so they ended up settling on Forest Park. But as you could see, they had their work cut out for them. There was a lot of things they needed to do to take Forest Park from a forest to a grounds that would be good for the World's Fair. So you can see some images here. You can see on one side what Forest Park looked like. And on the other side, you can see a sketch of what they wanted the World's Fair to look like. In a second, I'm going to ask you to pause. And I want you to look at these two images. And I want you to think about, what challenges do you think they faced taking the park from what it was to the 1904 World's Fair? There were many different challenges that people had to face in order to get the fair here in Forest Park. But one of the biggest challenges was the water. At that time, the River Des Peres ran through Forest Park. And much like the Mississippi, it was pretty muddy, and it wasn't necessarily the most visually appealing river. And again, people from all over the world were coming here, and we wanted to put our best foot forward. So we had to figure out, how can we clean up this river? How can we produce clean tap water? And how can we produce clean water for these fountains? Now, one of the things they did is they ended up putting the river underground. They dug a huge tunnel and redirected the river. And to this day, the River Des Peres still runs under Forest Park. That solved one problem, but what about the problem of the clean tap water or the clean fountains? Well, they figured it out, and that's also going to be your challenge today. It is going to be your task to try to take some water that looks like this and see if you can get it clean. So we're going to be doing this by building a water filter. Now you all, and maybe if you turn on a tap at your school or your home, clean water comes out. And that's because of the water filtration process. There are many steps in order to get the water from its natural source to your home or your school or any building. And we're going to be kind of going through those steps today. So the first thing you need to do is you need to gather materials. So I'll show you what you need. You're going to need some dirty water. So you can go and maybe get some from a pond or a river or a park near your house. I personally made my own. I took some soil and I put it in the water and I shook it all up. You'll need something to put your filter in. I have something a little bit fancy. I have this funnel and I have this tube that the water will go in. But you can do it at home by taking a 2-liter soda bottle, cutting it in half, and flipping the top part over and putting it in. Or if you think of another way to have a filter, do that. It's your job to be creative. You'll need some alum. Now this is optional, not everybody has alum laying around, and I'll explain what this is in a little bit. And you need materials for your filter. Now you can again get as creative as you want with these and find what's around your house. Now I'm at the museum and here's what I found. I have coffee filters, cotton balls, netting, sand, pebbles and marbles. So go ahead and pause now and go gather all of your materials. Now that we've got all of our materials, it's time to get started. But before we start actually building the filter, there's a few steps we need to take with our water. And this is true for the actual water filtration system, the water that comes from the creeks and ends up in your homes or schools. So the first step is aeration. What do you think that word sounds like? Aeration. Aeration is adding air to the water. This is going to release all of the gas that's been trapped. Now you might be thinking, how am I going to aerate this water? It's simple. You shake it. So you might be noticing, look at all of the bubbles up here at the top of the gas being released. I'm going to give it one more good shake. And there you go. You've aerated your water. The next step is coagulation. Coagulate means turning a liquid to a solid. So right now in our water, there's lots of gross dissolved things. And we want them to stick together. Right before the World's Fair, St. Louis chemist John Wixford discovered that if you added a combination of chemicals to the water, it would help those particles that had dissolved start to stick together. One of those chemicals was alum. Now, alum is very similar to salt, and it's used in many homes for pickling. But we can also use it to help get these particles to stick together. Now, you only need to add a little bit to your water. And again, this is optional. I know most people don't have this in their homes. Add just a little bit, and then shake it up. Now, what's important here is after we do this, those particles are going to start to get together, and they're going to start to sink. And this is the next process of the water filtration system, sedimentation, where the things start to come and settle to the bottom. Now, sedimentation is very delicate, and if we shake or move the bottle, it could disturb it. So I'm going to go ahead and I'm going to set this aside for right now while I build the filter. Now again, before I build the filter, there's a few more steps we need to do. Scientists just don't barge in and start their experiment or start throwing things together. They have to plan. They have to make hypotheses. And we're going to do that for our materials. So earlier I showed you the materials that I have, and you can see here on some scrap paper, I wrote them all out. I'm going to look at each material individually, and I'm going to make a hypothesis about how I think it would work in the water filter. So for example, for sand, I'm looking here at the sand. It's very fine, and I don't think a lot of particles could get through it. But I wonder, will the sand stay in my filter? What could I use to keep it in the filter? What if it fell through and made my water dirty? So I'm going to write down all of my thoughts right here on my scrap paper about my sand, what I think it might do. I think it might catch particles, but might slip through. All right, go ahead and pause now and write your hypotheses for each of your materials. I'm going to do the same. All right, so I made a hypothesis for each material and how I think it would work in the water filter. Now, while I was doing this, check out my water. You can see here that the alum is already starting to do its job. It's already taken those particles and has started sinking them down to the bottom. So the alum is already doing part of our work for us. This is also why it's important to set it aside and not move it too much. Now again, before we get into building our filter, we want to do a quick plan. And you can do this many ways. You can write out what order you want your materials in. I'm going to personally do a little sketch. And I'm going to write out next to it why I'm putting them in that order. It's important when we're doing a science experiment to think through why we are doing things and how we think they will work. So when we go back and improve it, we can kind of think about what did and didn't work and why we did what we did. All right, I've got my water filter all planned out, and now I'm going to build it. I'll be right back. So I went ahead and built my water filter, and you can build yours any way you want. Remember, you're going to choose your own materials and choose your own order to put them in. So we have our water filter built. Now it's time to test it. So I'm going to take my water and I'm going to slowly pour it in my water filter. Now, while you're doing this, scientists don't start experiments and run out of the room. You have to take observations. So I'm going to be taking notes as this is happening. All right, friends, are you ready? Let's see if my water filter works. All right, so I'm noticing it's coming out pretty fast. Oof, I noticed there's some particles in there. It's clear, but not 100% clear. All right, and a great way to test your water is to have some water from the tap handy to put right next to it so you can compare. So you can see here, I cleaned up the water a little bit, but it's still not as clean as the tap water. And that's all right, because this is the best part of doing a science experiment, is scientists rarely get it right on the first try. So you take the information from what you learned the first time and you use it to build an even better filter. So I'm gonna go back to the drawing board and I'm going to think about what I might do differently to improve it. And you're gonna do the same. At home, you can do this as many times until you get water that's just as clean as this tap water. Great job being scientists today and building your own water filter. Now, in the real water filtration system, there's one more step that we aren't able to do, and that's disinfection. Basically, that's taking all of the germs that we can't see with our eyes and cleaning them up so the water is safe and healthy for you to drink. We don't have the power to do that. So even if you build a water filter that's as clean as the tap water, you still can't drink it. Save that for the water that comes out of the taps. So after figuring out the problem to getting clean water, the designers of the World's Fair were able to build lots of new bodies of water with fountains and clean water all across the park for the fair, including the Grand Basin, which is still a popular feature in Forest Park today. The work done for Forest Park to prepare for the fair forever altered the park, and many of these bodies of water are still around Forest Park today. A man-made waterway called the Taylor-Kendall River runs through Forest Park. This is a man-made river, is about 2.5 miles long, and it follows a very similar path through Forest Park as the River des Peres did. Because it is an artificial system and it is still fed by tap water that has been dechlorinated so that plants and animals can live in the water. Forest Park Forever helps take care of the Taylor-Kendall River by removing invasive species, planting native plants along the bank, and monitoring the water chemistry. One cool thing they also do is they use alum to control any algae blooms that might happen in these bodies of water. Thank you so much for learning with Forest Park Forever and the Missouri Historical Society for April Virtual Homeschool Day. You can learn more by watching our other gallery stop videos and exploring our other Learning Day activities. You can also learn more about us by visiting our website at mohistory.org and Forest Park Forever's site at forestparkforever.org. You can find the links in the description below. Remember to please share with us anything you created on social media by tagging us and adding #MHSLearn. And remember, keep making history.